students, I welcome you to all our brilliant channel Maths Nation. Dear students, if you have not subscribed Maths Nation, kindly subscribe it now. I promise to complete your syllabus. Would like to solve your all queries which you may kindly drop in the comment box. So dear students, in my last sessions we have discussed about the nature of roots of quadratic equation depends upon the value of d. Today we continue with it. Here the question is find the value of k for which the given quadratic equation has distinct real roots. At first, please recall the nature of roots depends upon the value of d. The nature of roots of the quadratic equations depends upon the value of d. d equal to b square minus 4ac. When this equal to 0, this means the quadratic equation has two equal roots. This means the quadratic equation has two equal roots. The quadratic equation has equal roots means alpha is equal to beta. When d is greater than 0, this means the roots are real roots. Alpha and beta are real roots, are real distinct roots, real and roots. When d is less than 0, which implies alpha and beta are not real roots, Okay. Then next continue with some examples. Then here find the value of k for which the given equation. Here the given quadratic equation is px is equal to x square minus 4x plus k is equal to 0. Here px is x square minus 4x plus k is equal to 0. Then we have to find the value of k. Find the value of k for which the equation has real distinct roots. For which the equation has real and distinct roots. This means d is greater than 0. Then we have to show that d is greater than 0. Here the equation is px is equal to x square minus 4x plus k is equal to 0. Here a equal to 1, b equal to minus 4, c equal to k. C the constant, a the coefficient of x square, b the coefficient of x and c the constant. Then here d is equal to b square minus 4ac is equal to minus 4 square minus 4 into 1 into k. Then here as the equation has real and distinct roots, this means d is greater than 0. This means this is greater than 0. 4 square 16 minus 4k is greater than 0. Which imply 4k is less than 16, which imply k is less than 4. 4k is less than 4. Then the given equation has real and distinct roots for the value of k is less than 4. For the value of k is less than 4, the equation px is equal to x square minus 4x plus k. The value of k, when the value of k is less than 4, then this equation has real and distinct roots. Then next question is example 2. This question is already asked in the exam, previous year exam 2016 CBSE paper 2016. The question is asked. Here determine the positive value of k for which the two equations are given has real roots. Determine the positive values of k, means the k is positive here. Here the two equation is given First, P1x is equal to P1x is equal to x square plus kx plus 64 is equal to 0. Here another quadratic equation P2x is given x square minus 8x plus k is equal to 0. Here we have to find out the value of k for which the equation have real and distinct roots. Here to find out the value of k, to find out the value of k for which the equation have the two equations have, this is equation 1, this is equation 2, the two equation have real roots. Then you know the nature of the roots depends upon the value of d. When d is greater than equal to 0, then the equation have real roots. Here the d is equal to b square minus 4ac. Here d is equal to b square minus 4ac. Here for equation 1 d1 is equal to b1 square minus 4a1 c1, which is equal to, for equation 1 b is k square minus 4 into 64 into 1, which must be greater than equal to 0. Here k square minus 256 is greater than equal to 0. This means k square is greater than equal to 256, which implies k must be greater than equal to 256 square root, which equal to plus or minus 16, but the condition is given k must be positive number. Hence the k is greater than equal to 16. First, from d1 we come to the conclusion that k is greater than equal to 16. Then find out d2 of equation 2. d2 is equal to b2 square minus 4a2 c2. Here b2 is minus 8 whole square minus 4 into k into 1. As this is real roots means it is greater than equal to 0. Then this is 64 minus 4k is greater than equal to 0, which imply 4k is less than equal to 64, which imply k is less than equal to 16. From equation 2 we get k is less than equal to 16. From equation 1 we get k is greater than equal to 16. From equation 1 and 2, we come to the conclusion that k is greater than 16 or k is less than equal to 16, which imply k is equal to 16. For the value of k is equal to 16, both the equations, quadratic equations, equation 1 and equation 2 have real roots. Then next question. Here another question. If P, Q are real and P is not equal to 0. Here the conditions is given if P, Q and R are real and real numbers. P, Q, R are real numbers and P is not equal to 0. One condition is given. Then we have to find out that the equation given, equation P minus Q x square plus 5 into p plus q x minus 2 into p minus q is equal to 0 are real and distinct roots. These equations have real and distinct roots. These equations have real and distinct roots. This means when we find out the equation, quadratic equation of real and distinct roots, when d is greater than 0. When d is greater than 0, we find out the real and distinct roots. What is d? d is equal to b square minus 4ac. From these quadratic equations, b is equal to coefficient of x is equal to 5 into p plus q. A is equal to p minus q, coefficient of x square. C is equal to minus 2 into p minus q. Then here b square minus 4ac is 5 into p plus q whole square minus 4 into p minus q into minus 2 into p minus q, and for this we have to find out that this equation has real and distinct roots. This means we have to find out that d must be greater than 0. d must be greater than 0. Then here 5 into p plus q whole square, this is 25 p plus q whole square. Then this is plus 8 p minus q whole square. Look at here. This is a whole square number. This is a whole square number. This is also a square number. As p is not equal to q, this means p minus q is not equal to 0. As p is not equal to 0, q means p minus q is not equal to 0. Then here 25 p plus q whole square must be a positive number, because it is a square number, means it is a positive number. And 8 into p minus q square, it is also a square number. This must be greater than 0, means a positive number. Hence this is greater than 0, this is greater than 0. This means when we add 25p plus q whole square plus 8 into p minus q whole square, this must be greater than 0, which implies d is here greater than 0. As d is greater than 0, then the roots are real and distinct roots. This never be 0. Always d is greater than 0, because this is a positive square number, this is also a positive square number. Hence, as we find d is greater than 0, we come to the conclusion that the quadratic equation have real and distinct roots. Real and distinct roots. Next questions. I have already told you, students, please practice more and more questions. When you can practice, you only practice variety of questions, you can appear any questions which will be asked in your exam paper. Here or you must practice your worksheet and ask me your doubt. If any doubt persists, please ask me in my comment box. I will solve your doubts. Here P, Q, R, S are real numbers. Here P, Q, R and S are real numbers. And the condition is given that such that PR is equal to 2 into Q plus S. PR is equal to 2 into Q plus S. To show that the equation given here, x square plus px plus q is equal to 0, and another equation is given, x square plus rx plus s is equal to 0, has real roots. We have to prove that this quadratic equation 1 and quadratic equation 2 both have real roots. This means when the condition, we have to find out the real roots. You know, students, when the d is greater than equal to 0. when the value of d is greater than equal to 0, we can only find the real, both the equation have real roots. Then let us prove. Here the equation for equation 1, find out what is d1. d1 is equal to b1 square minus 4a1 c1. Here d1 is equal to p square minus 4q is equal to p square minus 4q. Then d2 is equal to b2 square. d2 is equal to b2 square minus 4a2 c2, which is equal to r square minus 4s. This is 1, this is 2, this is d1, this is d2. Then here d1 plus d2, here d1 plus d2. We have to show that d1 must be greater than equal to 0 and d2 must be greater than equal to 0. We have to prove this because we have to find out both the roots are real roots. Then here d1 plus d2 is equal to p square minus 4q plus r square minus 4s, which is equal to p square plus r square minus 4 into q plus s. Here the look at here. This is the condition is given PR is equal to 2 into Q plus S. PR is equal to 2 into Q plus S. Then in place of Q plus S, then here P square plus R square minus 4. In place of Q plus S, we can write PR upon 2. Then this is PR upon 2, 2 cancel. This is P square plus R square minus 2PR. This is S square plus B square minus 2AB form. This is equal to P minus R whole square. This is equal to P minus R whole square. As it is a square number, always it must be greater than equal to 0. As it is a square number, this must be greater than equal to 0. This means here d1 plus d2 is greater than equal to 0, which shows that d1 must greater than equal to 0 and d2 must greater than equal to 0. Then both are greater than equal to 0. Hence at least one of the two equation has real roots. Then either d1 must be greater than equal to 0 or d2. Both the numbers must be positive numbers. Then can we find these two quadratic equations both have real roots. Okay. Then students, today this much. Please note down, in my next sessions we will discuss about application of quadratic equations. Thank you students.